Hello, good day, wherever you are watching this video from any part of the world. I want to quickly make a short video on the Arrhenius Equation 2. I have done on one before. You can check my past video on Arrhenius Equation and you will see what I have explained there. Now, in this, I want to create the Arrhenius Equation 2, which is an extension from where I stopped. Okay, in the past video I have equally explained how you can plot your graph. Okay, when using the Arrhenius equation. Okay, how you can plot your graph in Arrhenius equation 2. Let's go back, let's recall. Okay, we are recalling the formula for Arrhenius equation, which is log k, okay, is equal to, no, is, I mean to say ln k is equal to ln A minus EA over RT. Let's call this equation 1. And if we are making it equation 1, I'll be making this one K1, I'll be making this one T1. Okay, that is when we are given different rate constant in a question and different temperature in a question. How do we address questions like that? It is for us to link it with this type of equation. Then we have ln K2. Actually, questions like that lead to simultaneous equations. So we want to solve the Arrhenius equation simultaneously now to obtain one single formula which we can use to solve problems like that. Instead of using the problem to create a simultaneous equation, then we are solving this on simultaneously now. Like for example, in the question where K1 is given to you, K2 is given to you, T1 is given to you, T2 is given to you. All this will be given, they will ask you to look for one, or all this will be given to you, they will ask you to look for the activation energy. Okay, where you have different rate constant and different temperature, how do you go about it? That is what I'm doing. So let us assume we have different rate constant here, a rate constant K1, T1, and a rate constant K2. This collision frequency factor, which is constant, EA over RT2. So I will be calling this one equation 2. So if I'm going to bring equation 1 and 2 together by subtracting equation 2 from 1, subtract equation 2 from 1, what do you obtain? From 1, meaning that you are saying that ln K1 minus ln K2. Please understand this English here, this sentence here, that subtract equation 2 from 1. It's just like you are subtracting 4 from 7. When you say subtract 4 from 7, what do you say? 7 minus 4 is equal to what? 3. So the same way, subtracting 2 from 1 means that this ln K1 minus ln K2 is equal to, please watch very well, this one will become ln A minus EA over RT1. Okay, subtracted to this, you are subtracting minus what? Because this is an expression, you will bracket it ln A minus EA over RT2, you can see. Okay, then this one will give us ln K1 minus ln K2 is equal to ln A minus EA over RT1. You open this bracket to give you minus ln A, then this minus this will give you plus EA over RT2. Okay, this already shows that if you do collection of like terms here, collecting like terms here, it means that ln A will cancel ln A minus ln A, it will go. So ln A minus ln A will go. That one will give you 0. Okay, then you will be left with ln K1 minus ln K2 is equal to what now? Minus EA over RT1 plus EA over RT2. What you have here, do you know you can make this EA over RT2 minus EA over RT1? And when you do that, that will give you this, that ln K1 minus ln K2 is equal to what? EA over RT2 minus what? EA over RT1. Okay, when you do this, what are you going to obtain? It means that you are going to have ln K1 minus ln K2 is equal to if you look at it, EA over R is common here, so you can factorize it out. You are going to have EA over R into the bracket of what will remain here. If you remove EA over R, it will remain 1 over T2. 1 over T2 minus what will remain here. If you remove EA over R, it will remain 1 over T1. This is the Arrhenius equation. On Arrhenius equation, when you have different rate constant and different temperature, and you are required to look for activation energy, or activation energy is given to you, but the question contains different rate constant, okay, and different temperature, you use this formula. If you check some other textbook, they work on this formula to produce more other formula. And if you can use this formula to solve any question, in as much as different rate constant and different temperature is given. If you solve this one, you are going to have ln, this formula can work for any question. Ln K1 minus ln K2 is equal to EA over R, all into the bracket of this T2. This, if you take the LCM of T2 and T1, you are going to have T2 T1. I mean T2 into T2 T1, it will remain T1. T1 times 1 will give you T1 minus T1 into T2 T1. T1 T1 will cancel to remain what? T2. T2 times 1 will give you what? T2. This is another way you can write this formula. This formula is the same thing with this one. I have only solved this to obtain this. Do you understand? So in a nutshell, you can use ln K1 minus ln K2 is equal to EA over R, all into the bracket of 1 over T2 minus 1 over T1. You understand? You can use that formula simply, or you use this formula. Ln K1 minus ln K2 is equal to EA over R, all into the bracket of T1 minus T2 over T2 T1. This formula can also go. I want to believe you understand what I have just done here. So with this, you can solve questions on Arrhenius equation. So this is a short video. I remain your humble tutor and your loyal tutor, Akpeji Honesty. I want you to share my video to other chemistry learners, chemistry students, science students in the secondary, in the elementary, in the higher institution, so that they can begin to have good understanding about chemistry. Okay, if this is your first time of watching my video, you can also share this video to people and encourage them to subscribe to my YouTube channel, and also put on your notification button, so that whenever I upload a new video, you will be duly notified. Thank you.